Okay, so we've got this question here. JHK, a stock exchange listed company, has in issue 6% redeemable bonds that are currently priced at 102 kwacha, 0.75 ngwe per 100 kwacha nominal. The bond is due for redemption at the end of year 8. Calculate the bond's yield to maturity. Basically, the rate of the bond. And what is the rate of this bond? So here we're going to use the same format of calculating the internal rate of return. Okay, the internal rate of return. So the first thing that we need to do, step one, in calculating the yield to maturity of a bond. Step one is you need to get the interest payments. Okay, so the interest payments is the interest rate multiplied by the par value. Okay. So here in this question, they told us the bond is, how I got the par value, it is here. They said 100 kwacha, 102.75 per 100 kwacha nominal. So this is the par value of the bond. Okay. This is the market price. This is how much you buy the bond for on the market. Yeah. So that's the first thing you need to do. You need to calculate the interest payments. After you get the interest payments, we need to make this table here. I'll come back to, I hope we remember this in from financial management in year 2. We were doing this. So, first things first, you make how many columns? 1, 2, 3, 4, 5, 6, 7. You don't really need to put this narration column, but it's just for your studying purposes. All right. Yes. So you start with year 0. Year 0 is the first day of year 1. You go to the Securities Exchange and you pay the market price for the bond. That's why we're representing this as negative 102.75. You are paying for this bond, so money is coming out of your pockets. After you purchase this bond, from year 1 to year 8, you'll be receiving interest payments of 6 kwacha. Okay, 6 kwacha interest payments. And at the end of year 8, the bond matures. And you get paid the par value, which is 100 kwacha. Okay. So the next thing that we need to do is now we need to tabulate our discount factors. All right, so our discount factors, we want to use this formula 1 plus r to the power negative n. Now this one will be used for one-off payments, okay, like for in year 0 and in year 8. Years 1 to 8, where you'll be receiving the interest payments, that is an annuity. Remember, colleagues, what an annuity is? The same payments over the same period of time. Okay, so each year you're getting 6 kwacha, 6 kwacha, 6 kwacha. So that is an annuity. Okay, so for years, the rate here is 6%. Discount factor at 6%. Okay, so here 1 plus r, that is 1.06. 1.06 to the power negative 0, since this is in year 0. So to the power negative 0, excuse me, that gives us 1. For the interest payments, 1 minus 1 plus r is 0.06. So when you do 1 plus 0.06, that's how we get our 1.06 here. To the power negative 8. we put the last year here, divided by 0.06. So let's get our calculators. 1.06 to the power negative 8. That is 0.627. Let's write it here. So you're going to say 1 minus 0.627, you get 0.373. Then you divide that by 0.06 and you get 6.21. All right. Okay, okay. Are we all getting 6.21? Okay. Year 8, you're going to say 1.06 to the power negative 8. That gives you 0.627. So to get our present value here, it's just the cash flow times the discount factor. So negative 102.75 times 1, that gives you negative 102.75. 6 times 6.21. Colleagues, what do we get when we get 6 multiplied by 6.21? 6 times 6.21, I'm getting 37.2. Okay. 100 times 0.627, you get 62.7. So we're going to add up now. We're going to say negative 102.75 plus 37.26 plus 62.7. We get negative 2.79. Yes. Before we go any further, any questions? This negative 2.79 is just the present. It's the present value, the net present value. These cash flows are like in the future. These six quarters you'll be getting, and these 100 quarters, it's money you'll be receiving in the future. So you convert it into the value today. So this process of getting the yield to maturity for a bond, this is the internal rate of return process. The same way we get the internal rate of return, the cost of debt is the same way you get the yield to maturity. And you're going to need to have two present values. One has to be negative and one has to be positive. So we're not yet done. Any other questions? Okay, so what happens is this. When you get, if your first present value is negative, you need to lower your discount factor because we're trying to get a positive net present value. All right. So we need to reduce this discount factor. So it's a matter of trial and error. Okay. Yes, you remember that technique, huh? Yes, you divide it by two. Okay, so our new discount factor is going to be at 3%. Okay, so we do the same process again. So instead of 1.06, now we're dealing with 1.03. 1.03 to the power negative 0, that is 1. We get our annuity factor. Let's get our calculators to get this annuity factor. Do I have the tables here? Colleagues, do you remember how to use these tables? The tables? Let me just get the tables also. But before that, we had divided by 0.3. The tables will be provided in the exam. That would be okay. That would be a good thing. Here's the formula here. Our discount rate, 3%. Number of years, 8 years. So our discount factor will be 7.020. 7.020. Those who are doing the calculations, you get a value close to this one. Let me know if you get a value close to it. Then 1.03 to the power negative 8. Here we come to our present value table. 3%. Number of periods 8. So we go 1, 2, 3, 4, 5, 6, 7, 8. 0.789. So we do the process again. We're multiplying the cash flows with these discount factors. So you say negative 102.75 multiplied by 1, negative 102.75. 6 times 7.02. What is 6 times 7.02? 42.12. 100 times 0.789, 78.9. So let us add negative 102.75 plus 42.12 plus 78.9. What value do we get? What value are we getting? All right, 18.27. Yes. So now we can get the yield to maturity using this formula. Remember, the yield to maturity is just the total return you expect to get after you hold the bond for 8 years. Okay, this total return includes the interest payments, any capital gains, or any capital losses. So A represents the lower discount rate. In this case, our A is 3%. B represents the higher discount rate, which is 6%. NPVA is the net present value with the lower discount rate, and that is 18.27. NPVB percent represents the net present value with the higher discount rate, which is negative 2.79. So it's just a matter of putting it in the formula. So we're going to say A percent. We'll say first here. A percent plus NPV A percent over NPV A percent. NPV A percent minus NPV B percent, then B percent minus A percent. If you want to make life easy, instead of using A, you can use L so that you remember that it's the lower discount rate. Instead of using B, you can use H so that you remember it's the higher discount rate. Because I know at times you might forget and say you might take A percent as the higher discount rate. Okay. You might switch them up. So it's usually good to use L and H. So the net present value with the higher discount factor, 18.27 divided by 18.27 minus. Now, colleagues, I'll need you to get your calculators so that we see if we are all getting the same number. Okay, because in the exam, you'll be alone and you have to punch this by yourself. So you need to make sure you're punching it correct. So let's get our calculators. The one in the brackets here, 6 minus 3%, that's 3%, that's easy. 18.27 plus 2.79, 21.06. And you say 18.27 divided by 21.06, 0.687, 0.867. Multiplied by 3%. So 0.867 times 3%, you get 2.62%. 3% plus 2.6%, you get 5.6%. If you want, you can round it off to 6%. And that is the yield to maturity, or the total return you get after you hold this bond for 8 years.